you froze it, so it's no longer a video, but if you push Cine Loop, now it's a video, this is your loop, and if you push Image Store now it'll save that.
Well, you guys can
So that is now your video loop. And you know it's a video because it doesn't have a little one by it. See how that one has a one and that one has a one, those are still things. Okay? So we're going to trace that one, try to find another one.
I mean, the initial process is a bit slow, and then it kind of ramps up. So you guys
And that is a beautiful, long left ventricular chamber. That's what most people will do to look for a function. Now this actually will work too. See, this is your aorta. Get the cleanest aortic valve there, so fan your transducer back and forth until you get there. That actually will work too. I'm going to save that video loop. I'm going to save a couple of those. It's better to do transverse, but this is get the cleanest aortic valve there. So this is aorta, this is left atrium and mitral. You just have a sideways view instead of an upside down view. Okay?
Right now they want all 12 people
Clean up that aortic valve. I want to see exactly where each one of those cusps attaches.
Yeah, I don't have enough experience. And I know that each university is a little bit different. Some universities are more prone to like give pets.
And you only want the stroke volume on the left side of the heart.
Which is why they get a lot of innovation.
Because you're doing a left-handed thing. I bet you get it faster with your right. It's just you just finesse it down.
Basically gets that.
Yeah.
Which is a shame.
It seems like Susie's pretty amiable, that sort of thing. The only thing I'm not sure is how much they
I think I'm actually gonna bug out. Okay.
go through Susie Richards, they can
See ya.
Yeah. Thanks a lot.
What are you doing?
Yeah.
Hi.
I'll make sure I send you these videos.
Okay.
Thanks a lot.
You know, just let me know if you guys want to come in here and practice.
Okay.
We'll do. Okay, so just let me know if you're down there. You can almost see exactly what you're attached. Since you have to sweat over this too much because your other method's going to be better. There. You see how nice that is? We'll save that video. Okay. Now, turn transverse 90 degrees. It doesn't matter which direction you twist. Stay exactly in that place, and you'll get that transverse aorta coming up there. This is your pitch valve. It's the mitral valve in a transverse plane. But point towards this heart base, and you'll get the aorta right there. There you go. And then just slide around a little bit there until that's really pretty again.
And I guess like when you're just starting out, you haven't done it before, you don't have anyone in the group that has, it probably doesn't hurt.
they're really good at stuff.
Just slide it towards that heart base.
It's
a
really
little bit.
tricky that
It is one here, one here, and one here. Okay? And so that's your ideal picture. You want to see these nice cusps. So I'm going to save this loop. Okay? Bring it back into play. And then I'm just going to do an image store. And that's now saved here as well. Okay, so now you're going to start measuring for your stroke volume. All right. So on this picture, we can make it look a little better by adjusting the gain a little bit, just making it look a little crisper. Okay, just compressed is the same thing. You're just making things look so our edges are cleaner. Okay.
So if I want to do that compress, how do I get over to
So it's highlighted here. Okay, and right or left buttons. Reject is the same thing. It just rejects low. So it doesn't seem to be doing much here. Oh, didn't do anything. But anyway, we're going to freeze that. Push the 2D button. And you're going to use the trackball. Come all the way to the beginning of your loop. Okay. And just go forward. You're going to watch this valve open. And then you're going to watch it close. And then right before it opens again, okay, you'll keep scrolling through. I'll show you. So I'm just going to come over here at the beginning. So the valve's closed, right? It just opened. Okay. I'm going to go forward until I see it close again. So it just closed. It's not very clear right there. See how you can barely catch the hint of that Mercedes? But it's kind of a fuzzy border, so I'm going to keep going until I get a cleaner border. This is what you should say when you're starting to do this for your study. Save a bunch of loops because some of them just don't look so good when you freeze them and start scrolling through. Okay. Anyway, so here we have a pretty nice transverse aorta. Decrease the gain on it again. Okay. All right. Ready? This is our picture. All right. You're going to push measure, and we want an area. That's right. See how the caliper comes up. It looks like it's in the place where you want to start. It doesn't necessarily do that, right? But that's a great place to start. And so you're going to literally trace the outline of this aorta. So I'm pushing set wherever I want to start. It doesn't matter where you start. And you're going to trace. And if you don't go right, you can just back up. It'll just back its way out. Okay. You don't have to get too crazy about the teeny little, like that kind of stuff. Okay, it doesn't make any difference in the long run. Have the area is 4 centimeters, 4.3 centimeters squared of this aorta. Okay.
And that's the cross-sectional area?
Of the aorta, yeah. And you should do several of them because as you can see gain and all that kind of stuff, how bright and red and everything is. So we're going to actually, I'm actually going to see if we can get them
We had to
to be
perform emergency open
more useful units for you.
I'm pretty sure no one's survived. Yeah, it was pretty tragic. We had to stop the heart for like 2 hours.
Millimeter square, no more accuracy, something like that? Sure.
Luckily, it was
Okay, I'm going to highlight
really
the other
excited
one. You
just
had
to
one
see
here.
that go.
Go ahead and find a frame. I think the quality of this one's just a little bit better, so how are you going to measure that area?
Yeah. 'Cause I mean,
There's only the
yeah,
2D
but
button next to it,
what's
so
on there,
find your
we're into, like,
caliper.
fumbling around,
Pull that
it
picture
comes
back
out
up.
through
It was number
through the
14.
micro, like, oh my gosh, how did we miss that? You know, back in there.
Now, it's the 2D button that'll freeze this loop, so go ahead and push
But I'm
that.
excited.
Okay, now you can use your trackball. So find a really nice picture of that aorta. They're just open. You see the valve cusps through right along the walls here?
Yeah.
And you should get this right before it opens, okay? Because that's going to be the largest, or just as it's opening, that's the true spot to measure aortic area.
Okay, so you don't want to measure it when it's closed, you want to measure it when it's just
And
opening?
it can, just opening. It can be closed right before it opens, but it's always better if it's just like right there. But see how the quality just went back?
It's amazing.
So I'm
You
going to
can
come
really
back
see
over
on that
here.
one.
Yeah, but I'm starting to see how you get an eye for what's in there. I mean,
When you're scanning, you'll know eventually. This
Yeah.
is so. See how that just started to
Nice.
open there?
Yeah.
So I would trace that right there. Okay. So how are you gonna do it?
Well, he might not, I mean, I guess
Now, what do I just press the set button?
That's right.
Although these
That's a
things
good video. I have to sort of
sometimes-
hog it a little bit, Rachel, or it's off to the side and
You
it's blurry.
just hog it.
you can
It's
always
still a little blurry, but off to the side it was really bad.
If you want to come and here,
And you kind of have to extrapolate this part a little bit, right? Because we kind of lost some detail there. But these will get better and better the more you do them. You know it has to be a circle, right? You're kind of making it a backwards D, right? So exactly. So come
Round it
around a
out.
little bit more.
Tell Mike.
Yeah, we need another one.
There, that looks a lot better, right? And eventually you'll get to where it actually has a nice clarity for you. You'll just be a good enough scanner. So this is very similar to what you had before, except that now we're in millimeters squared.
I think we're good to get that through TSA.
Yeah, and I think his new.
This? Oh, yeah.
So it would be 4.79
You could carry this on.
centimeters squared if you want
Carry
to
it on,
kind
probably
of-
not. But,
Yeah.
maybe put it
Sure, you
in
can put it in
your
your suitcase.
Eventually you want to,
Even then
your
it'll probably
multiplication
take a
will
look
be
at
in
it.
centimeters.
Yeah, I don't
Okay.
so getting it in centimeters is fine.
Well,
Now, how,
actually,
how
the
if I want to
way
change it
to
from millimeters to centimeters, do I do it again?
Config, click area, which is the measurement that you want, or any of the measurements that you want to change, and come up here and change it back to centimeters.
I do off fuel testing.
And this has a precision of 1, so let's make it 2. Does it do 2 for us? Maybe not.
But
Maybe it won't allow us to do 2. You're only going to get a precision of 1. Well, that's the way it is. Okay, so push config again to get out of here. All right. So now you're going to go to one of your aortic flows. And you should do, the rule as a general thing for cardiac measurements is to measure 3 cardiac cycles. So you should do 3 of those aortas. Okay. And we're going to do 3 of these aortic flows, but we're just going to do 1 to start with. So pull up one of those pictures.
We use, there's a lot of super moving qualities.
Okay. So now go to measure. And we are going to go to aortic, because that's the flow that you're measuring, right? And you're going to do an aortic valve trace.
Where did you guys get the?
And you're going to start this, you're going to start this right at the baseline, right where the flow starts. Okay? And push set. And you're just going to trace this. Again, all those little kind of jigs and jigs and the big scheme of things don't change anything. And you're going to pull this up. This is where the aortic valve goes up right from that.
They don't match.
Okay. And then it wants a heart rate, so it's moved it to the start of the next heartbeat, so I neglected to do that. So make sure, like if that was a good one, you could have traced that and gone to here for that next heart rate. We're just going to pretend it's right here. Okay? Because that's what gives you your heart rate, so you can get your cardiac
So we're gonna be
output.
able to fit this
Okay?
guide wire
So I'm
and
just
the.
going to pretend it's right there.
down
The
there?
heart rate is 66. It's pretty close to that.
Is
Okay?
this one
So
on?
now, on this particular picture, this aortic valve flow time integral, okay, is 23.8 centimeters.
So it does the integration for you.
Yep.
What do you think?
Nice.
Yeah, very nice, isn't it?
What do you think of
And so now you have centimeters here. This is the distance that this volume moved during ejection. And you have a centimeter squared for your aorta, and if you multiply them, you have a stroke volume. So let's see what a stroke volume is. Do you have a calculator on
Why does this
a